In the preceding videos, we looked at basic camera controls, the ISO, shutter speed and aperture. Now let's see how these translate to a digital camera, and let's set it up so we can go out and shoot our first exercise. In this example, we will look at the Canon 5D Mark III. If you have a different camera, the chances are that the controls will be laid out slightly differently, but again, the underlying principles will be the same. Modern cameras are extremely sophisticated, so if you want to get really comfortable with your camera's controls, it is very important that you read the camera manual. Even though it may seem daunting at first, you may discover some extremely useful functions hidden deep inside the menus. The first thing you'll notice is that this camera does not have an aperture ring on the lens, nor the shutter speed dial on the top plate. Instead, we have the mode dial, which allows us to select between different shooting modes. The main shooting modes are program, aperture priority, shutter speed priority, and manual. P stands for program. In the program mode, the camera controls almost everything on its own and automatically sets the shutter speed and aperture. TV stands for shutter priority. In this mode, you set the shutter speed and the camera automatically sets the aperture to obtain the standard exposure. For instance, if we are shooting a bicycle race speeding past, we may select the shutter speed of 1/500th of a second and let the camera automatically select the corresponding aperture. AV stands for aperture priority. In this mode, you set the desired aperture and the camera sets the shutter speed automatically to obtain the standard exposure. For example, if we are shooting a portrait, we may decide to set the aperture to f2.8 in order to blur the background. After we select the aperture, the camera will automatically select the corresponding shutter speed. M stands for manual. In this mode, you take full control of the camera and set both the shutter speed and aperture. To determine the exposure, we use the camera's built-in light meter and refer to the exposure level indicator in the viewfinder. We said that the modes are selected via the mode dial on the top plate of the camera. To allow us to control the shutter speed and aperture, the camera has two additional dials, the main dial at the front and the secondary quick control dial at the back. In the manual mode, the main dial at the front controls the shutter speed, whilst the secondary dial at the back controls the aperture. If you switch to the aperture or shutter speed priority, the main dial at the front will control the aperture or shutter speed, and the secondary dial at the back will control the exposure compensation. In other words, the function of dials changes according to the shooting mode you are using and can usually be customized using the camera's custom functions. Notice that as we turn the dials that control the aperture and shutter speed, the digital camera uses aperture and shutter speed scales divided into thirds of a stop, not whole stops that we saw on an analog camera. These finer increments are put in place to allow us more precise control over the exposure. White balance control tells the camera the color temperature of the light source we are shooting under and ensures that white objects appear white in pictures. Most often, auto white balance will obtain the correct color temperature, but we could also use this control creatively. For example, analog films are usually daylight balanced, so if we set our white balance to daylight on an overcast day, we may get a slight blue cast which could give us the look of an analog film. Another way of setting the white balance is by using white balance targets such as the X-Rite's Color Checker Passport or QP cards. To set the white balance this way, you would take a picture of the target and set the white balance in camera or take the reading later in software. This camera has 4 different metering modes. Evaluative metering breaks up the frame into a large number of cells and uses the camera's built-in microcomputer to analyze the scene and interpret the meter readings. This is the camera's most advanced metering mode, and left on its own will probably give us the most accurate exposures. Partial metering covers approximately 6.2% of the viewfinder area at the center and can be used with backlit scenes where the background is much brighter than the subject. Spot metering is weighted at the center, covering approximately 1.5% of the viewfinder area, and is useful when we want to take the reading from a specific area of the scene. Center-weighted average metering is weighted at the center and then averaged for the entire scene. What this means is that the meter divides the frame into 2 areas and then takes 2 readings, one from the center and another from the periphery of the frame. It then averages the 2, but it gives more importance to the reading taken from the center because it assumes that the subject is always in the center of the frame. We will talk about metering in more detail in a later section, but for now we can safely use evaluative metering as standard. Drive mode allows us to control how many frames are taken at one time. In single shooting, when you depress the shutter release button completely, only 1 frame will be taken. High-speed continuous shooting will take 6 frames per second, low-speed continuous shooting will take 3 frames per second, etc. On this camera, drive mode also allows you to select one of the self-timer settings. Autofocusing modes tell the camera whether it is expected to focus on static or moving subjects. One-shot mode is suitable for static subjects. When you depress the shutter release button halfway, the camera will lock the focus and wait for you to take a picture. The camera will also usually beep, or a green circle will appear to indicate that the focus has been achieved. AI servo mode is best suited for moving subjects. While you keep the shutter release button depressed halfway, the camera will track the subject and focus continuously. AI focus mode automatically switches the AF mode from one shot to servo if a still subject starts moving. Apart from the AF modes, the camera also allows you to select between different AF area modes. These allow you to change the size, position, and number of active focusing points, and because these can vary greatly from one camera model to the next, it is really essential that you read the manual for the camera you are using. The ISO sets the image sensor's sensitivity to light and should suit the ambient light levels. We said that the low ISOs like ISO 100 will give us the best image quality, but they require lots of light. Higher ISOs like ISO 1600 will result in noisier images but will allow us to shoot in low light conditions. Digital camera technology is constantly improving. In the days of film, ISO 100 was considered slow and fine-grained, whereas ISO 400 was considered fast and somewhat grainy. On the newest digital cameras, however, you may find that there is very little discernible difference between ISO 100 and ISO 800. It is therefore best if you do tests with your own camera to determine what levels of noise you find acceptable. Before we go out shooting, there are a few other controls we need to set, and these are usually hidden in the camera's main menu. picture styles control how the colors are rendered and are similar to choosing between different films. For example, Fujifilm cameras have picture styles such as Provia or Velvia to suggest that these are essentially digital emulations of their analog film stocks. You can leave this on standard or experiment and see which picture style you like the most. If your camera is set to shoot in the RAW file format, you can change this setting afterwards. Image quality selects between different pixel counts and image quality settings. However, the most important choice here is between the RAW and the JPEG file. If we set our image quality to JPEG, most of the important decisions such as exposure, white balance and picture style are taken in camera and cannot be changed after the fact. For this reason, we can liken the JPEG to a Polaroid. If, on the other hand, we set our image quality to RAW, many of the important settings can be tweaked in post-production. When working with the RAW file, we can change the white balance, we can fine-tune the exposure to retrieve information from highlights or shadows, we can change the pixel count, etc. For this reason, we can liken the RAW file to a film negative, which holds much more information and can be manipulated in the darkroom to make the final print. Because of the many advantages it offers, you should set your camera to always shoot in RAW. The gamut of reproducible colors is called the color space. With DSLRs, you can usually set the color space for captured images to either sRGB or Adobe RGB 1998. Adobe RGB is the standard in professional photography and offers a wider gamut of colors. However, if you only show your images online or on the screen, the sRGB may be a better choice. Once again, if you set your camera to shoot in the RAW file format, the color space can be changed in software later. This way, when you want to make a print, you convert your RAW file to Adobe RGB. When you want to publish your image on a website, you use the sRGB color space. Lastly, before you go out to shoot, you need to format the memory card. Formatting will delete all the data on the card, so make sure to back up the existing images first.